Welcome to everyone for joining the webinar. Today's one's going to be about the Symo Hybrid with the new BYD premium battery box HVM model. So the Symo Hybrid is only compatible with the HVM version of the premiums, but the start of the webinar will go over in general the new premium range, as that will be then compatible with the new Gen 24s as well. So let's get started. So yeah, my name's Rod Dewar. So hopefully a few of you will know me. I guess I've been with Fronius for around or going on 10 years in September. I've got my colleague Balaji, who's also been with Fronius for quite a long time, and he's part of the tech support team. So he'll be helping out with some questions if you've got them. And so let's have a look at a bit of the agenda. So we'll do a bit of an introduction, as I said, to the premium range, and then how that works with our inverters or with the Symo Hybrid, the various setups and the components that you need. Then we'll go a little bit into the architecture and setup and assembly and communication to the inverter. We'll cover a little bit about the warranty, and then about some of the operational modes and temperature behavior, etc. So in the hour, it's going to be hard to cover absolutely everything in fine detail. So, but this is really to give you a good overall view of the capabilities and how to calculate for, let's say, battery charge and discharge, what your options and things are, etc. And we will then go through some of the questions and hopefully cover all that off. So just as a start, really, so Fronius and BYD partnership, we've been working with BYD for a few years now. When they brought out the BBox HV series, we did the integration with them, and that's been working with the Symo Hybrid ever since then. So got a really good relationship with BYD. They're a massive company in China, huge. You could say they're bigger than Tesla in terms of batteries, and pretty much all the electric cars and buses that are used in China are made from BYD. They've got a great support network here, and been a great company to work with so far. So yeah, the introduction to the BBox premium range. So the previous ones were called BBox HV, and so these ones the battery box premium. So with the premium ones, some of the new things they've done, they've changed the design of it. So I personally think it looks a lot nicer, let's say, at an aesthetics point of view. Still got a very high what do you call efficiency with those. They're still using the lithium iron phosphate in terms of the chemistry, so we're not using the NMC technology. So it gives you a good high charge and discharge rate on that. Also, they don't have the LFP doesn't have that issue with being at high state of charge for too long. So I mean, that's always controllable, and that's always you can always handle that. However, intrinsically, this type of battery doesn't have that. So we'll just cover off the HVS and HVM. So as I said before, I'll keep reiterating this a few times throughout the webinar, is that the Symo Hybrid that we're covering today is only compatible with the HVM, and I am only doing the current Symo Hybrid at the moment. So the Symo Gen 24 is coming out in next month, end of September, October is coming. So we'll do a separate webinar to cover off the compatibility and how that's implemented, etc. This is just for the current Symo Hybrid range. So they do have the HVS and HVM. They have two different ranges with that. So for different storage variants, really, some of them are higher, higher power with less capacity is the HVS, and your HVM stands for medium, which is then a higher capacity with a bit less power. So there's the cost of the two, as far as I know. I mean, we don't sell them, but they're similar. the HVMs are slightly cheaper per kilowatt hour as opposed to the HVS. They do have a compact design, so it's taking up less space in the same amount of energy that it was with the previous model. Another improvement is you have an LED on the front, which is the power push button, which has an LED ring around it, which flashes in various colors. So that gives you now an indication of what the battery is actually doing. You know, is it discharging, is it charging, or is it idling, or if there's an error or something like that. So that's the improvement on the previous model. Installation they've made even easier. I found that the previous model was very easy to install, being separate modules. You could do it with one person. You didn't need a special lifting device, etc., etc. You just need to have a good breakfast in the morning, and you'll be right. And so they've made it even easier in terms of the interlocking of the mechanism between the modules on that too. And another thing is the parallel connection with the previous one. It was planned to have a parallel connection between them. However, that never really came to fruition because they were making up a DC, what do you call, combiner type box, which was a bit pricey, etc. And so that never really kind of went ahead, or at least from our perspective. With this one, this is will be a lot easier to do, the parallel. So you can have up to 3 storage towers, just with the comms connection between them and the DC connection back to the inverter. So that could potentially enable up to 66 kilowatt hours with 3 times the 21.1 kilowatt hours. I've got yet to be confirmed or to be confirmed in there because we're currently doing the testing at the moment. We have seen some others using this in the field already, and it already works. And we're fairly confident it will work. And the initial tests we've done have been good. However, we don't have an official, let's say, confirmation of that yet. So, but it is looking good. So at the moment. So a few other things about it. So yeah, cell chemistry is your lithium iron phosphate, so your LiPo4. The HVS, again, as I said, this is not with the Symo Hybrid. In general, the HVSs go from 5.1 to 10.2 kilowatt hours in a single stack, and the HVMs go from 8.3 to 22 kilowatt hours. The maximum discharge and power rate of the series, you can get up to 9. As I said, that's not with the Symo Hybrid, that's with the Gen 24. The weight per module is 38 kilos. You've got a good temperature range from 10 to 50, IP55, so it can be used outside. Obviously, you want to try and keep it out of the full weather, so not in the sun. No lithium batteries like the sun, really. And the communications via RS485, so MODBUS RTU. There's a few specs on the batteries down the bottom there. So you've got the, let's look at the HVM, because that's what we're using at the moment. So you go from the 8.3 capacity, which will be 3 modules, and they're connected on top of each other, and that goes up to 8 modules with the 21.1. You can see the kilowatt hours of each module is very similar. The main difference you'll notice here, and this is why the power difference is different later on, and why one has a higher power than the other, is to see the actual the module power, or module voltage, so to say, of the HVS is higher than it is with the HVMs. So that'll have a bearing on the maximum power that you can have with each battery module going forward. But we'll get into that in a bit more detail later. I said again, so that slide's kind of repeating a bit. You can see here, starts with a HVS, would do 5.1 in a single stack, and then go up to 3 stacks of 12.8. Not all of those will be compatible with the Gen 24s, the different stacks. We'll have to go into that into the next webinar. However, for the one we're looking at here, HVM, starting off with 8.3 is a single stack of 3, and then potentially, as I said, when we've finished the testing, 3 stacks of up to 22.1. So if you look at the specs here, so with the medium one, so the HVM series is the one we're going to concentrate on now because that's the one compatible with the Symo Hybrid. You can see the 3 modules here because they're connected in series. The current is always the same. It's always 50 amps from the battery perspective. However, the voltage, the nominal voltage increases the more modules you have. And obviously you have voltage time current is your power. That's why the power increases the more modules that you have. Okay, so if we start off at this lower one, you'll have your current input of our inverter, which is 16 amps, times the nominal voltage will give you your power. And I'll do some calculations on that later and be able to see how to work it out. So you can see here the voltage increases, starts at 153 and goes up to 409 with the biggest stack on there. Okay, so what components do we need for it? So some of you might be familiar already with the Symo Hybrid in itself, maybe used with other batteries. So you do need the 3 main components for the configurations. Obviously, you need the inverter, which comes in a 3, 4, or 5 kilowatt AC across 3 phases. Then you need a Fronius smart meter, and you need the battery itself. So as you can see in the little diagram there, if you do have, let's say, 8 kilowatts of PV here, because of the MULTIFLOW technology, and we'll go through that a little bit in the next slide, you can have 8 kilowatts DC coming in and producing 5 kilowatts AC and 3 into the battery at the same time. Or let's say maybe 3 kilowatts AC and 5 into the battery, depending on what's going on. Okay, here's a bit of an idea, just a basic diagram of how it's connected. So you obviously have your inverter, which is then DC coupled to the battery. You also have your DC from the modules into the inverter itself. You have the smart meter needs to be connected into the main switchboard because that's an important part of the system because it needs to know what power is excess and what power is then going to and from the grid, so it knows what to do with the battery. You can also have other AC coupled inverters on there too, so in parallel. So the meter will see any excess energy and it will then pull that into the battery. So you can have it charging from DC and from external AC at the same time. So that's what we call, I guess, our MULTIFLOW technology. Can do EPS mode, so it's a backup mode. That's one thing I forgot to mention potentially at the start of this video. So I won't be covering the configuration and the capabilities of the backup, the EPS mode. Because there's so much to cover in that, we'll do that in a separate webinar another time. But the backup scenario is pretty much the same as a previous BYD B-Box. So there is already a webinar on YouTube if you want to look at that on how to wire it up. We will do an updated version of that, which covers the BYD Premium HVM as opposed to the B-Box HV. You've also got full visualization in SolarWeb as well of what the battery's doing. So here, when we talk about MULTIFLOW technology, we're talking about multiple directions of power flow within the inverter or within the system. And so you've got here, let's say PV. It's out of the box. It will run in maximum self-consumption mode. So it'll always try and cover the loads first. If you have any excess PV, let's say the PV is producing more than what the load is, then the excess will go into the battery. If it's the other way around, if the load is higher than what the PV can produce, then the rest will be taken up by the battery. Also, when you're charging, so when you are charging from PV, you can charge from PV, or if you want to top it up from any other AC source, you can do that, and it will then charge with AC and DC at the same time. You can do it with time of use. So let's say you want to set up maximum minimum charge rates from the grid, or if you're in off-peak tariffs or various tariffs, you can charge the battery at a lower tariff if you like, and then and use it to discharge at a higher. Give you those kind of possibilities. You could also do AC coupling. You don't have to have PV connected to the hybrid inverter itself. You can just use it as an AC coupled battery charging system. If you've got an existing PV three-phase inverter there, or even a single phase, but obviously a three-phase site, you can connect that in an AC coupled mode, and then it will then charge from this PV inverter. One thing to note that if you do this one here, then in backup mode, when the inverter goes into backup mode, it does run at a 53 Hertz AC signal, and it does that in order to kick off any AC coupled inverters because it can't control it in backup mode. But in normal grid connect mode, obviously it can. All right, so just to cover off some of the smart meters. So obviously needs to be a three-phase smart meter. So we've got various types there. Some of you may be familiar with them. So we've got the Direct Connect 63 amp one here. It's a DIN rail mounted, it's 4-pole device. Obviously 63 amp per phase with a 16 mil connection. That sits in the switchboard, and you have your grid coming in and out and your loads on that. If it's a bigger site and you want to use one with CTs, we have the 50 kA model. Again, 4-pole device, DIN rail mounted. However, it uses CTs. And CTs on this one is 5 amps, so you need your 5 amp secondaries on this one. Yeah, I mean, some of these specs here are because of you might use them on 2-phase sites, but for this, it's not relevant. The other one is the 480 volt UL meter, which is a flat pack type device. Also uses CTs, but uses a 333 millivolt type. That's for situations where you may not have enough space in the switchboard, you can use that model there as well. All right, so some of the main features, I guess, advantages of the Fronius solution with the BYD Premium is it's a 3-phase, it's a real 3-phase system. Can produce a real 3-phase backup. Obviously can power single-phase loads as well. The scalability, from 3 to 8 battery modules of the HVM, 8.3 up to 22.1 for a single stack. And again, as I said, potential multiple stacks in future. We're fairly confident with that, but it hasn't 100% been confirmed yet. Nice, easy installation, and using the MULTIFLOW technology for your charging. All right, so I can see a couple of questions that come there from maximum charge and discharge rate. So I guess having lots of different options then is good. Can sometimes make it a bit more complex in terms of working out what battery size or size do I want, and what do I get from that. So in terms of the maximum charge and discharge rates, there's multiple things that determine this value. So the inverter's AC rating will determine it. So let's say the battery may be able to do 5 kilowatts in and out, but if you've only got a 3 kilowatt inverter, then obviously that's the limiting factor. Also, the inverter's DC input current is 16 amps on the Symo Hybrid. So that always needs to be taken into account. Even though the battery can do 50, our input range is only 16 with that, so you need to take that into account. Then the other thing is then the battery voltage. Okay, that'll determine it too. So let's look at an example here. So I've highlighted, put the HVS in there, but you can see it's been blanked out because it's not compatible with the Symo Hybrid. So the HVM series here, this gives you the table as to which battery and which inverter will give you what charge and discharge rates, okay? So an example here, HVM 11, it has 204 DC nominal, roughly. So that'll give you, that times 16 will give you 3.26 kilowatts. So if you've got a 3 kilowatt inverter, then that'll be 3 only. If you've got a 4 or 5, then you'll get that full 3.26. So in order to get like the full roughly 5, you'd need around the 16 kilowatt hours for the HVM in the single stack with that. Okay, so make sure you consider that when you're considering the battery size with those. Okay. All right, well, let's look at the system architecture and a bit of the setup on there as well. So the main things you'll need is you'll obviously need DC cable for this, the hybrid inverter, smart meter, the battery, and then your installation materials. So, I mean, some of these will depend on the installation because you will need to bolt the battery to the wall, etc. You will need Cat5 shielded Cat5, so that's one thing to really be wary of. It does say it in the manuals. I know a lot of guys use normal, you know, your C-bus cable, etc. However, you do want to use shielded for it because it's using with the battery. Your DC cable with it as well. So it is only 16 amps, you know, maximum current. So depending on your cable run, you know, if the cable run's really short, then you could probably get away with 4 mils fine, or 6 mils squared. You can do with that. The terminals can take up to, I think it's 22 or 20 mil, I think it is that. But yeah, you don't need that because you're looking at a high voltage, low current battery. So these are just some of the excerpts out of the installation manual from the BYD. So I haven't copied and pasted them all in here. Again, you want to download those documents and go through those before you go to site, so you get a bit of an idea of what needs to be done here. So it comes that the HVM and HVS modules can't be interconnected. And the BMU for the HVM HVS is the same. However, in this case, we're just using the HVM, of course. So you got your base, which you then level out with a level, and then each module then stacks on top of each other like this. And then you've got the locking screws, which then lock in to lock each device in with each other. Okay. So it's pretty straightforward in terms of me, and the BMS goes on top. Then you've got your mounting bracket, which then mounts into the BMS. That then prevents the battery from being tipped over and being solid on the wall. Connections to the battery. So this is what the battery looks like. We'll just go back that page here. So the connection plate is on the left-hand side. Here, this little dot here, you can't see, that's the LED and a little power button on the front of the battery. And to the left-hand side, you've got your connection plate with all the glands, etc. One of the things about the connection plate to note is there's a little safety switch in there. So if you are doing some testing before you seal it up, etc., then there's a little micro switch which you need to kind of click in. It's like a protection thing. So if you're doing testing and you're finding it's not working or not finding the battery, it may be because the little micro switch is not activated. This is the little micro switch there, just here, and that gets pushed in when you push the side panel back on. So here's your earth clamp. Here you've got various connection points for your communication. So either via RJ45 or via a terminal block. We'll cover that off in a minute. You've got your dip switches here for your 120 ohm resistor on there as well. And obviously your DC cables here too. So they come then from the inverter, your earth and your DC coming in and your communications. We do recommend you don't have to have communication to the battery. It does have a web server in there. I think as far as I know for the warranty, you don't have to have it in there. You don't have to have it. However, we do recommend having it because it gives BYD a lot of insight as to what's happening. Also, in the case of a warranty case, or let's say it's potentially doing some weird things and you want it to be looked into without having to go to site, then having a connection to that is very advantageous with that. It is only via Ethernet though. There is no Wi-Fi connection for the battery. But as I said, it's not essential for that to be connected for the battery to work or for the warranty, but in service cases, it would be of an advantage. So we'll just go through the two variants here. As I said, you've got the variant of doing an RJ45, so network type connection. So the one end at this end here would be using this connection block here. So you've got your pins 1 and 2, which are your MODBUS here, D+ and D-. and then you've got your pins 7 and 8, which is your negative and positive terminals. So the negative is then for your ground, and the positive, like the B-Box HV versions, the positive was used to detect that the battery is connected or the battery is there. So essentially four wires for your comms there. And these are the pinouts, etc. here. So you can have, depending on where you have the battery, you may have the battery in the middle point or the end point, but again, like any RS485 connection, the midpoint needs to be, or the two endpoints need to have your 120 ohm resistor activated. So in the case of our smart meter, that's then the physical resistor. So the physical resistor that's connected there if you're used to mounting the smart meters. And at the battery end is your that's your dip switches there. So the midpoint, which is your data manager from the inverter in this case, that would be then switched off. And I've got some slides to show you that as well. The second variant is to use this terminal block, which they have here. So that would be using your bare cables for that rather than a plug on the end. And this is showing the wiring diagram, and use pins 5 through to 8 with the corresponding pin outs here. So all this documentation, this is taken out of the BYD or Alps Power quick commissioning and configuration guide. As I was mentioning before with your Modbus, so this is what the connection area looks like. These little dip switches here, you want to have all of those facing left to have the 120 ohm resistor on there. So depending which option you want to have, inverter in the middle, smart meter in the middle, or battery in the middle, that will determine if this is on or off in this case. So it's the middle one there. Most cases, it's usually the inverter in the middle. So in that case, you really want to make sure that at the bottom of the data manager antenna, where the antenna is screwed on, there's a tiny little mini switch there, little micro switch. That little micro switch has a little on-off. You want to make sure that that's turned off, because that then disables that 120 ohm resistor. All right, so what I'll do, I see quite a few questions coming there. Maybe I'll still might wait to the end. Keep your questions coming, and I will cover them. We'll just keep going, and then we'll go over them at the end there. So commissioning inverter and the battery itself. You'll need some kind of smart device for it, be it your phone or a tablet or something. You can also do it. So the commissioning of the battery, you need a smart device. You can't do that via a laptop. So the first thing you want to do before doing all this is download the B-Connect app from BYD. That's their battery commissioning app for this. So you get it on the, obviously Google Play or Apple App Store. It looks like this, and then install that before you go. So probably a good idea to that before you go into site. So the current status or version of the app at the moment is only for commissioning. However, there's a new one just about to come out, which does have more, let's say, more features for servicing. So you can open up the service part of it, and you can see the battery voltage, the state of charge, any errors, all that kind of stuff. So a lot of troubleshooting and things through that. So once you've downloaded the app, then the first thing you want to do when you open it up is you want to select the language, etc. Is before you connect yourself to the battery itself, you want to download the firmware. So you download the firmware onto your phone, and then doing that stores the firmware in the app, and then after that you can then go ahead and connect to the battery. So in order to connect to the battery, you can see that's the big DC breaker on the right hand side of the battery, and it looks like that. That's right here. So when you turn that on, that automatically activates the Wi-Fi access point on the battery, and so you'll see that pop up, and it'll be a BYD XX whatever model it is, will pop up as the network name. And then you put in the WLAN password. The BYD B-Box is the password to get into it. And so as I said, that access point will start automatically. So once you connect to that, then you can open up your B-Connect app again. and you then go through, you want to do the firmware update because you've downloaded it beforehand. If you don't download it beforehand and connect to the battery first, then it'll try and do a download firmware, but the firmware, you're trying to download it from the battery, then you're not connected to the internet, so you need to do that beforehand. So this is a bit of idea what happens within the app. So I'll ask for the time and date, which inverter model. So hence that's why you need to update the battery first. So the inverter will come up with a Fronius, either a Symo Hybrid or a Gen 24 will be the options. Select that, then it'll ask you for which battery model it is. Also, how many modules it has in there, with which it is, so HVM or HVS, or then which modules. Also, if it's a grid system or off-grid, because these batteries can be used in off-grid situations, not with our inverter. Obviously gets used for backup, but not for full off-grid systems. It'll ask if it's 3 or single phase as well. Then it will go through a confirmation thing, and then you've completed it. So fairly easy and straightforward with the app there. Then for the inverter, you'll need to make sure that you update the firmware on the inverter. So that needs to be done. I'd recommend, because that does take a while. It can, depending on your internet connection, can take anywhere between like 45 minutes an hour to update the firmware. So if you can, get that connected to either DC or AC. One of the things on the Symo Hybrid, it has a dual power supply inside, so you can actually power it from either. So power that up if you can, get it connected to the internet and update it while you're doing other things, rather than having to wait at the end for that. So the latest firmware, the 1.16.6, is the one with the new BYD premium integration within it. So I'm not going to run through the whole commissioning of the hybrid manager and how you do it. That's that's been done kind of before. The only thing which is different is when you go into it and the system overview, or let's say that selecting the battery, you want to select the BYD Battery-Box HV is what it's called. So that's for the old school H or the premium ones. Through that. So then in terms of support and warranty claims, so the support partner here for BYD is Alps Power, and for Alps Power, their service line, they're very helpful in terms of their service. They've also, as I said, they if they have remote access to the battery, then they can do a lot of things there to help you out if there's any issues. And one of the main things important, I'd really recommend doing this before you go to site, and that's this here, this download page here, Alps Power and their download section. All of their quick guides and the information about the battery and configurations, etc., is all in there. So that's really a good idea to read that before you go to site. All right, so we'll just cover off a little bit of operational modes. So give you an idea of the SOC of the battery. So the normal operating range is between 5 and 100% SOC. If it gets down to 5%, then the inverter stops actively actually charging or discharging the battery, and it'll go into like an energy saving mode. If there's not enough excess and the battery self discharges over a long time, and it gets to 3%, then the inverter will try and charge it back up to 8% and puts it into standby. So this will just kind of continue and make sure it stays at 8% if it gets down too low. And yeah, once it hits 8%, then it'll go into its normal standard operating state rather than in the energy saving mode. You can see the status of the battery in SolarWeb. You can see it in here. As I said, it'll show, if there's a little eye icon here, you want to click on that and it'll give you the information if it's in energy saving mode, or let's say it's in startup or standby or something like that. That gives you the information there. That's also visible on the local web interface as well. So in terms of temperature, I guess with the last one, there was some limitations with the B-Box HV with some limitations in temperature. So when you got down really cold, under 0 degrees, you had reduced power, and also when you got in the hot range. That is the case technically from the battery side of things. You can see, you know, the HVM, if it's within the normal, you know, 0 to 50 range, then it has 56 amps, but when you go down to a lower range, 45. But because we're limiting at 16, there's no change in charge or discharge rates with the inverter at any of those temperatures. So in SolarWeb, this is what it would look like. As I showed a little picture before, this gives you the SOC of the battery, and you can see everything, what's going to and fro the battery there. And also in the daily chart, the history chart, you can actually see, you know, what's going to the battery, the SOC, and if it then discharges, etc. as well. Okay, so if you want any further information on, let's say, the operating manuals, etc., go to our download sections on our website. We'll also be bringing out a whole bunch of trainings and different events, so feel free to visit us on this site as well. So, all right, so that's the end of the run through. So I thought I'd go over some of the questions here. Balaji, maybe you can jump in.
Hi, Rod. Thank you very much for the detailed presentation and the webinar. Really handy for everyone doing the BYD HVM installations. So I got a couple of questions answered to our customers, and I thought, you know, it's good to read out some of the questions so that everyone stays across the same page. So I'll just prioritize those questions for you. So one of the most commonly asked question was, is it possible to have multiple Symo hybrids in parallel on one site? No, it's not possible with the default Fronius gear, but I'll let you to answer this question, Rod.
Yeah, okay, so that does sometimes come up. So yeah, unfortunately from Fronius's point of view, it's not possible to have them in parallel. One of the main reasons is we don't have the SolarNet connections or SolarNet communication loop with the Symo hybrid. So kind of out of the box, that's not possible. However, there have been a few people that have done it and using either external controllers or using multiple meters, because the main thing with the Symo hybrids and the way it's been designed, originally at the start when it was designed, it wasn't designed for larger systems. I mean, hence the 5 kilowatt as a 3-phase. However, we did see a benefit for bringing it to Australia. So because the communication loop between the inverter, the battery, and the meter is running on RS485, then in that loop you can only have one master, and the master in that loop is the inverter. So hence you can't have another inverter in that loop because you'd have two masters then. So because of that, you can only have one meter connected per inverter. So the only way you could potentially do it would be to have two parallel separate systems doing their own thing. We have had a couple of people do that before, and I think the results have been okay. However, we haven't tested it, and we can't tell you exactly how that performs. Another way is through a third-party controller, like the likes of Reposit or some other ones there, potentially switched in would maybe be able to do it, but that's something you would need to clarify with them.
All right. Yep. Thanks, Rod. And the next question was, you know, one of the customer was asking, let's say if the inverter is on an islanding mode, why is it not possible to have the PV working together with the Symo hybrid? So obviously, when the inverter is operating in the backup mode, the Symo hybrid, it increases the frequency, but I'll let you to provide a detailed explanation on that as well.
Yeah, that's correct. So the reason, so obviously in normal grid connect mode, the grid frequency is 50 hertz. But then when you go into backup mode, we purposely run the inverter at 53 hertz because most of the trip settings on the Australian setups of inverters is 52 hertz. So it purposely trips them off. And the reason why we purposely trip them off is because When you're in an island and you have an AC coupled, our inverters actually being the grid, you need to be able to control that either via frequency or via some kind of comms. You could potentially do that with, a Fronius. You would think that, okay, how come Fronius can't do it with that? It's just we haven't implemented that into the software. It would be a lot of effort to get that implemented, and so it's not really planned to do that, especially I guess with some of the newer models coming out. So we can't do it with the Fronius ones, and then being able to control other inverters would be also potentially tricky, maybe per frequency shift, etc. But that hasn't been implemented as a feature, so hence that's why they don't work. Back to you, Balaji. You got any more questions there?
Yeah, Rod. One more question I got for you. Let's say in a backup mode, in one of the phases, if the power consumption is too much compared to the other phases, where will the excess power flow through?
So when it's in backup mode, so the inverter only produces enough per phase that there is that the load is there, because obviously it's got nowhere to go. So if you have, it's a 3-phase site. Let's say you have 1 kilowatt on phase 1 and maybe 2 on phase 2 and none on phase 3, then it can do that. That'll just produce a maximum of 3 kilowatts, and obviously divide that into the phase where it is need to be used. So it can do an imbalance. So let's say a 5 kilowatt inverter, normally in grid connect mode, it would be balanced across those phases, which gives you 1.666 roughly per phase. It can, however, do around about 2 kilowatts on one of the phases as an imbalance. So yeah, but if anyone's after some more information on that, I recommend them looking at our EPS, our Symo Hybrid EPS webinar video, which is on YouTube. Yep. As I said, that one does cover the HV at the moment, but we will redo that going forward.
Okay, so in that case, the excess power will flow through the neutral conductor, yeah?
Yeah, that's right. Yeah, so then in that case, in a normal on-grid 3-phase, you'll have no current in the neutral because it's fully balanced across the phases. But in backup, you'll have obviously current in the neutral, and you'll always have that if you're running an imbalance out of a 3-phase inverter.
Okay. All right, Rod. That's most of the questions that I had. So that's pretty much from my side as well. Thank you for answering all the questions.
Okay, no worries. I'll have a look and see if there's. I'll just have a quick look here and see if there's any. So the maximum, I think someone's asking maximum load it can handle. That's again, recommend looking at the one of our other webinars on that one. So in terms of the in terms of backup circuits, the wiring and things of that, we have looked at potentially doing a box for it, but that's still on the cards to look, because it's very difficult to know which countries it'll be work for and what particular parts are needed within the box, etc. as well. That's something we'll cover more in that other webinar. So I think someone asked there in regards to the Symo Gen 24s. In terms of paralleling those. So when you parallel them, they will be parallelable, not from the very start, but potentially once we have the full inverter to inverter communication, which will be coming approximately mid next year. But there's no definite date on that. That's roughly when it be coming. What's here? So I've got someone asking about in terms of commissioning, which ones to commission.
Sorry to interrupt you there. So since you mentioned about the inverter to inverter communication on a Symo Gen 24, so it would still be possible to have 2 Symo Gen 24s on the same site without any batteries. They can function as a normal grid-tied inverter separately, but it won't be able. Could you please clarify on that, Rod?
Yeah, no worries. So with that, so with the Gen 24s, when they're coming, so without the inverter to inverter communication, they won't be able to communicate with each other in terms of, let's say, battery control, etc. However, you can have two inverters on the one site and have them separately connected on SolarWeb, and they'll all join together on SolarWeb in terms of the data. Also, export limiting will be possible, except depends on the export limit. So if you have a 0 export, then that'll be difficult at the start. You'll need to you can only do it with one inverter at the start, but going forward, you'll be able to do multiple ones as well.
Okay, great. Yeah, thanks.
So let's say, what else we've got here? Let's see, someone asking here. So I think someone was asking for so maximum distance between the energy meter was one of the questions. There's no maximum, kind of is 300 meters. Would be using the MODBUS communication. You can do 300 meters with that. Using a wireless solution, that's difficult with the battery. The wireless solutions that most people have been using have been from supply partners, which is their USR wireless device. However, we wouldn't recommend that for a system that has a battery because you have multiple slave components in there, and we've noticed that the latency of the conversion can cause issues. But if it's just an inverter with a meter, then that seems to be working fine. So there may be some other solutions out there, but however, we haven't considered that yet. So let's see here. So someone's asking about we've got here. So the communication between the Symo and the grid tie inverter, I think I mentioned that before. That's not planned, not with the Symo Hybrid. With the newer inverters coming, we will potentially be doing that. However, with the Symo Hybrid, there's no plans to do that at the moment. They got one of the New Zealand guys we have for support in New Zealand. So Aaron, yeah, so with the New Zealand thing, I mean, New Zealand's a bit of a special market when it comes to three-phase because they, they charge per phase. It's the only one other country in the world that I know of that charges for that charges that way. It's Czech Republic. So you need to be able to do asymmetrical feed-in for that, which the Symo Hybrid is not possible. With the new Symo Gen 24s, that won't be possible to start. It is something, however, we're looking at getting implemented for that, but there's unfortunately no timeline on that. So I think someone's asking for the link for the where is it here? Yeah, I'll put that up. Someone asked me for the links for the BYD downloads there. What's another thing here? So, so yeah, the Symo Hybrid DC output or input thing, it's only for high voltage batteries. So hence the HVM is high voltage medium. So we're not compatible with the low voltage types of that. Someone else has asked 300 meters with RS485. That's correct. Yes, it can do up to 1,200 meters or a kilometer. That's true. However, for the reliability of the comms, we only recommend 300. So, I mean, it probably likely work above that. However, with the communications that we use, we just recommend it's 300. I mean, I don't think I've had anyone yet who's need to do more than 300 yet, but who knows? Maybe a first for everything. So the Symo Hybrid, someone's asking if it'll be phased out with the Gen 24. So eventually it will, of course, but that's a little while away. So the first Gen 24s off the rank of the larger ones, the 6, 8, and the 10, and then eventually the 3, 4, and 5s will be also things, but that's probably not for quite a while yet. But that is the plan, yeah. So that's an interesting one. Does the COM smart meter need to be on a separate conduit? So that's a real interesting one at the moment. In my opinion, it doesn't. And I'm in talks with a few people on this one. Some people say it does. So look, that's really up to your inspector. At the moment, I am trying to get some clarity on that to provide that to installers. It definitely needs to be rated for the highest voltage. So looking at your C-bus cable, so you can't use your normal blue stuff. From a rating point of view, it needs to be the pink stuff. Or, I mean, there's others probably out there, but that's the most common. One thing I have managed to clarify though for people is with the C-bus cable, using that, there was some situations where people said you can only use it on C-bus equipment because it says it on the box. And so if you go by AUS 3000, it says you got to go by manufacturer's instructions, and if you follow that by the letter, then you basically can only use it for using with C-bus stuff. However, been in touch, I managed to get some clarification on that from Clipsal and Schneider. And so if anyone's interested, we just let us know through tech support. We do have a letter from them saying that's fine to use it with our equipment. So in case you get any questions on that. But yeah, so someone's put that is 240 volt rated comms cable, the C-bus stuff. So. But yeah, the other one in terms of the separate conduit, that's a different topic with that, which I'm trying to get some clarification on that. So, all right. So I think I've pretty much covered off most of the questions. If there's anyone wants to throw in any last ditch questions there, I'm more than happy to try and answer anything with that. So I'll just double check, see if there's anything else there. So someone asked, yeah, the Gen 24's being released. So the Symo Gen 24 is coming at the end of September or October. There's only small numbers landing in the first month or two, and then the numbers will ramp up. The Primo, the single phase one is due in around calendar week 12 in 2021 is the plan at the moment. So for those of you who and this time I know it's been delayed quite a few times. This time we've requested from our R&D that they give us a more solid date. So all right, so I mean the only one thing which I maybe forgot to mention I didn't have in the actual presentation is so CPD points. Someone asked that. Yeah, we got 40 CPD points for this, so that's fine. One of the things when you're doing the commissioning, and I did forget to put that into the webinar there, is when you're turning it on, you've done your commissioning, you want to turn the battery on first and then turn the inverter on. And the reason for that is the BYD has a special safety mechanism in there that it looks for or detects any DC on its input. And when you have the inverter switched on, there's always a bit of leakage voltage between the inputs. So if you've got your PV there, then you get a bit of leakage voltage through to the battery input. And so if the battery sees that, it won't start up. It'll shut itself down. So so yeah, when you do that, if you see having issues, you want to turn the battery on first. Leave it for, I don't know, 10 or 30 seconds. That's enough, and then you can turn the inverter on, power the inverter up, and do it that way. Okay, all right. Well, I think that's covered off pretty much anything there. So we'll go through the end. Oops, there we go. All right, well, we'll leave it there. So yeah, stay tuned for coming webinars with the Gen 24. We'll run through how to commission those, some of the different features as well. We'll also what batteries are compatible and go through the BYD range of that, because the Gen 24s will be compatible with the HVS and the HVM, so it gives you even more choice. And we'll go through EPS configurations, etc. as well in the coming. So stay tuned and have a look, and yeah, look forward to seeing you next time. All right, catch you later, guys.
Thank you, Rod, and thanks for joining the webinar, everyone, and you guys have a great weekend. See you guys.